Hello, I'm here to talk to you about the scientific revolution. And the first thing we want to look at here is the way that the um, traditional natural philosophy really was organized and the way that people thought. And I try to explain that for you in the first part of the lesson, but just some overall things I want to point out here first. The first thing is that the science before the scientific revolution was not just simply ignorant or dumb or based solely on things that nobody could prove. There was a real effort to try to understand the world, going back all the way to Greek philosophy, okay, and the astronomy of Ptolemy in the ancient world. And so when European Christians, and specifically European Christian intellectuals, were trying to talk about the universe and describe the universe, they were building on an ancient tradition. Okay, and as you can see in the description, Aristotle's ideas were really important here. The way that the universe hung together, um, organized in, again, a hierarchy where everything had its place. In the Ptolemaic system, God lived in the heavens and people lived on the earth. There were the planets going in perfect circles around the earth. This was a system that really did try to see order in the universe. And Christians also thought that Aristotle's ideas and the ideas of the natural philosophers fit with Christianity too. Okay. And so we want to try to look at that in something of a sympathetic light. You don't have to think that, oh, they were thinking about it better. It's just trying to understand why people thought that way is a really important part of history, and not just to sort of sneer at the past and say, well, people were a lot dumber back then. Aristotle was no idiot, right? And so there was a genuine attempt to understand the cosmos and see how things all fit together. Here we have, as I've pointed out, the Ptolemaic system, the Earth at the center. And over on the right-hand side, we have the model of the epicycles. All right. If you look at the stars, as far as I understand from what I read, if you look at the stars and try to track them, it appears that they go in one direction around the Earth and then they cut back. And so astronomers looked at this at the universe here and thought that there were these kind of epicycles, cycles within cycles, as the stars went around the Earth. And so this was part of the astronomy of the period too, the practical tracking of stars. Natural philosophers apparently didn't worry too much about the epicycles, but for astronomers that was important because it was the only way to really have a system that predicted where the stars would be. And it did a pretty good job overall. Okay, so you can read more about that traditional science or traditional natural philosophy. Secondly, I want to address some myths about the scientific revolution. I've already alluded to one of them, but it's not just a period where science bursts onto the scene and overturns a bunch of dumb ideas. Instead, there were scientists who stuck to the traditional natural philosophy and still made important discoveries. And really, you couldn't prove in this period before sometime in the 1800s that, for example, the Earth really did move. That was when somebody could do an experiment, I believe, with a large pendulum to try to prove that. Owen Gingerich, who's writes about science, talks about how the bigger picture of why so many scientists came to accept that the Earth was not at the center of the solar system, but that the sun was that Copernicus's model and those who built on him explained a lot more and did so more simply Okay. Secondly, this isn't really a period of science versus religion. That's really not a particularly useful way of thinking about history, in my view, especially because the scientists of this time were themselves religious. Okay? Galileo was religious. Kepler was religious and saw himself as trying to understand God's ordered cosmos. Isaac Newton was religious, even if he had some rather unorthodox religious beliefs. These were religious people, oftentimes, and who didn't see a conflict between their scientific interests and their religion. Okay, even if they did sometimes get into conflict with religious authorities, like Galileo did. Okay, so those are some important myths to address. The third thing I want to tell you is about the scientific method, just something to look for here. One of the key ideas here is that the scientific method becomes a really important and prestigious way of determining what's true through the scientific revolution. Okay, one of the real defining characteristics of the new science is that the new scientists insist on observing, and whether that's observing the planets, observing the heavens, right, observing nature, or setting up experiments to do controlled observations. They insist on observation and the gathering of data and the using of that data to build something like a hypothesis, a theory, and theories about how nature works. Okay, Aristotle and the traditional natural philosophy that we see at the beginning of the lesson was much more deductive and much less interested in observation. Okay, observation was there, but the systematic observation and experimentation that the new scientists did was really setting them apart. Okay. So what are some ways that we see some change in continuity? Well, Copernicus, you can see this drawing here of his idea that the sun was actually the center of the solar system. He was an astronomer, and he thought that proposing this would make for a more elegant system. He was a tremendous mathematician as well, and he also had gone back and tried to revive some of the ancient ideas about astronomy. Okay, so he was looking backward as well. He didn't necessarily have new evidence for his system, but he did think that this system made for the models work better, or made the calculations and observations work better. Okay, Tycho Brahe was a great observer, and his assistant Johannes Kepler was, who's down here, came up with the idea of the elliptical orbits. Okay, here you can see a comet going around the sun with a very long elliptical orbit. The planets' orbits are pretty close to circles. They're ellipses, but they're pretty close to circles. And it's a good thing, because otherwise temperatures would vary pretty widely here on Earth. It would not be livable if we had an orbit that looks like a comet. So again, lots and lots of gathering of information was important. Galileo really perfected the telescope for his time to use for the observation of space, and that was, of course, very important. Okay, in the bigger picture, we can also think about how not only did scientists do science, but we got to think about, well, why were some people involved in this kind of stuff asking the questions they were? And that was partially because the discovery of the New World and all the different plants and animals were there that did that Europeans didn't know about, that was destabilizing to science as usual and helped to create some opportunity to look at things in a different way. So did the perfection of the development of the telescope. So did the development of mathematics and the use of more mathematics in science. Okay, and so also did the creation of scientific societies and patronage by rulers allow these ideas to spread too. So if just the scientists were doing this by themselves without connection to the larger society, it probably wouldn't have gone anywhere. But in the lesson, you get some ideas here about how these new scientific ideas spread. Thank you.